Hello students, welcome to Anne's classes. Let's do sets chapter 6, exercise 6a. Page number 74. Question 3. Write the following sets in the set builder form or the rule method. This is another name for the set builder form. Now what is the set builder form? So can you see here we have the elements of the set, the actual elements of the set. Whenever you write the actual elements, it's called the roster form. But in the set builder form, we don't write the actual elements, but we write a rule or a formula in the form of a statement so that we can understand that these are the elements. So now, first let's begin by saying B1. This is the name of the set, B1, and put curly brackets. And when we write the set builder form, we write it like this. X is such that X is. Okay, that means here X stands for every element here. So what is every element? So first thing we need to understand what the elements are. 6, 9, 12 and 15. What do these elements look like? These numbers look like they're multiples of 3, isn't it? What are all the multiples of 3? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12 and so on. But here as you can see, this 3 is not there in the elements of this set. So how do we write that? How do we write a statement to show that only these are the elements and it goes on, but 3 is not included? So since it is a multiple of 3, we start by saying 3n. Okay? And n belongs to natural numbers. Let's say n belongs to natural numbers. And natural numbers are numbers that start from 1 to, starting from 1, 2, 3 and so on. Now if I say this is 3n. That means in the place of n, I can put any number starting from 1. So if I put 1, 3n will become 3 into 1, which is 3. But 3 is not there. So what can I do here? I can say n is equal to 1. Okay, so n is equal to 1. If n is equal to 1, then this becomes 3 into 1, which is 3. 3 into 1 is 3. But I don't have 3. Now how do I make this 6? I can make this 6 by adding a 3 here, isn't it? That means I add a 3 here and I add a 3 here. So now this becomes 6. So now I have a formula 3n plus 3. So let's substitute that n with all the natural numbers, a few natural numbers and see. So when we put 1 here, 3 ones are 3 plus 3, we get 6. Now let's use that formula again. This time in the place of n, let's put 2. 3 twos are 6. 6 plus 3 is 9. Let's use that formula again. 3n plus 3. Now in the place of n, let me put 2. 3 twos are 6. We put 6 plus 3 is 9. Now let's put 3. 3 threes are 9 plus 3 is 12. Again use the formula. Now in the place of n, put 4. 3 fours are 12 plus 3 is 15. So now can you see we've got these numbers 6, 9, 12 and 15 which are all part of the set. So this is a formula that you can use, 3n plus 3. So let's write that, 3n plus 3. Now we need to write one more part here. Now n belongs to natural numbers, isn't it? We cannot say n belongs to whole numbers. If we say whole numbers, then n should become 0 also, which we will not get this answer. So we have to be very specific and say n belongs to natural numbers. We cannot leave out this point. So we have to say that. And now close brackets. So this becomes our set builder form. X is such that X is 3n plus 3 and n belongs to natural numbers. That means I can start by writing n as 1. I can put 1, 2, 3, 4 and so on. And when I add it to 3, I will get this. So this is my first answer. Second one, set B2 is 11, 13, 17 and 19. Now what are these numbers? These are prime numbers, isn't it? So how do I write this set? I write B2 is equal to, now put your curly brackets and write this, X is such that X is. What is X? It's a prime number, isn't it? 11, 13, 17 and 19 are prime numbers. So you can say X is a prime number. But something important there. Does it mention all the prime numbers? No, it says prime numbers between. You can say is a prime number between 10 and 20. Between 10 and 20. So now if you see, you have these numbers. So when you read this, you should get this answer. So your set builder form should be a formula that will help you understand that these are the elements. Now let's go to the next one. Now look at this one here. Let's start by writing B3, set B3 is equal to what? Now look carefully and see. Now we have 1 by 3, then we have 3 by 5, 5 by 7, 7 by 9, and so on, isn't it? So first thing you need to do is identify the pattern that is formed here. So here we have 1 by 3, that is 1 plus 2 is 3. Then again we put 3 there, the same base there, 3 plus 2 is 5. Again we put 5 there, 5 plus 2 is 7. Again you put 7 there, 7 plus 2 is 9, and so on. So this is going on like this. So in the place of 1, we can write n. Okay. Now how do I get 3? Now n is 1. To get 3, I'll say n plus 2, isn't it? Now if n is 1, so I'll write it here. If n is 1, then in the denominator, I'll say 1 plus 2. So what do I get? 1 by 3, and I've got the first one. Now if I use the same formula again, what will I get? So if I say n by n plus 2, this time instead of 1, here I put 1, here I'm going to put 2. Let's see if I put 2 whether I get. So this is 2, and in the denominator, in the place of n, I'm putting 2, 2 plus 2. So this becomes 2 by 4. But look at my second fraction here. It's not 2 by 4. So I cannot put 2. So what number can I put there to get 3? I need to put 3 itself. So I'm going to use the same formula, and in the place of n, I'm going to put 3. So in the place of n, if I put 3, then down also in the place of n, I put 3, 3 plus 2. So this becomes 3 by 5. So here n is 3. Here n was 1. Now again, can you see a pattern? This is 1, this is 3. So what do you think the next number should be? It cannot be 4, isn't it? It has to be 5. So let's use the same formula. So let's use the formula n by n plus 3. This time let's say n is 5. So if n is 5, in the denominator I say 5 plus 2. It's not 3. 5 plus 2. So what do I get? 5 by 7. So I've got the next one. So here n is 1, here n is 2, here 3, here n is 5. So 1, 3, 5. What numbers are these? These are odd numbers. And because they begin from 1, they are odd natural numbers. So what you have to do is first identify the pattern, get a formula, substitute with numbers, and understand what it is. So here let me start by saying x is such that x is equal to n by n plus 2. So I've written the formula n plus 2. But again, something very important that we need to write here is that n is a natural number and it is also an odd number, isn't it? 1, 3, 5, 7. So I need to write that again. I put a semicolon and I say n is an odd natural number. Odd natural number. So I have to make my statement very clear. So odd natural number. Now close your brackets. Let's read this. X is such that x is equal to n by n plus 2, and n is an odd natural number. That means in the place of n, I can put any odd natural number starting from 1. I can put 1, 3, 5, 7, 9, 11, and I will get these fractions when I put those odd natural numbers in the place of n. Okay. Question 4. Question 4. B4 is equal to 8, 27, 64, 125, 216. So first let's begin by writing this part. That is B4. Set B4 is equal to x is such that x is equal to, now we have to find a formula. Now what are these numbers? Look at these numbers carefully. What is 8, 27, 64, 125 and 216? They are all cubes, isn't it? If I take 2 cube, 2 into 2 into 2 is 8. If I take 3 cube, 3 threes are 9, 9 threes are 27. Similarly, 4 cube is 64, 5 cube is 125 and 6 cube is 216. So first thing you need to do is identify these numbers, identify the pattern or what numbers these are. So these are all cubes of numbers from 2 to 6. There are no dots, that means it's very clear it's only from 2 and stopping at 6. So now we have to make a formula. So what we're going to do is take 2, 3, 4, 5 and 6 as n. And then we say n cube. That means x is equal to n cube. Okay, so if x is equal to n cube, then n is 2, 3, 4, 5 and 6. So let's write that here for our information. So n is 2, 3, 4, 5 and 6. So now we can understand when we say n cube, we are saying 2 cube or 3 cube, 4 cube, 5 cube and 6 cube. That means these are all natural numbers. So we have the first part of the formula. Now we need to complete it and make it very clear. And n belongs to natural numbers. This is the second part. Now natural numbers start from 1, but here we don't have 1. So here also we should write very clearly what n is. N is equal to 2 and it's greater than 2 also, and it's equal to 6 and it's lesser than 6. Now how do we show that? So I can put n in between. Now n is greater than 2 and it is less than 6. But can you see? It also includes 2. So that means we say less than, greater than and equal to 2, less than and equal to 6. So in this case, you can include 2, you can include 6 also. So this is the other part. Let's read this. N is greater than and equal to 2 and less than and equal to 6. So let's write that also here. So that will be 2, we write 2 first and here we write n. And again here, and learn to read this also children. How do we read this? Take the middle letter. N is greater than and equal to 2 and less than and equal to 6. So now it is very clear what all these elements are. So what are they? N cube. And what is n? N is a natural number. And which natural number? Number that is greater than and equal to 2 and lesser than and equal to 6. Now we can close our brackets. So we've got the set builder form here. Question 5, B5. What are the elements? Minus 5, minus 4, minus 3, minus 2 and minus 1. So let's write that first. So set B5 is equal to, put your curly brackets, x is such that x. Now what is x? As you can see, they're all negative numbers. That means they are integers. So you can say x belongs to integers. So first thing you can say that x belongs to integers. What is the symbol for integers? You can put z or you can put I. Now integers means what? There are so many. You have positive, you have negative. So how do we show this? So let's take these elements here. Minus 5, minus 4, minus 3, minus 2 and minus 1. Only this many elements. So n, what is n? Okay, like we did for the previous one, we can start with this number. N is greater than minus 5. Okay, so I can put minus 5 here. But since we are including minus 5, we can say equal to minus 5 also. And n is lesser than minus 1, but it's also equal to minus 1. Question 6 here now, set B6. So let's write that. Set B6 is equal to, and let's put curly brackets and write x is such that x is what? Now we have to look again at all the elements and see the pattern. We have minus 6, minus 3, 0, 3, 6 and so on. Can you see dots here and dots here? That means on both sides it's going indefinitely. That means x belongs to integers. X belongs to integers and you can see that they're all multiples of 3. So you can write that. When you say multiples of 3, we just say 3n. That means n can be 1, 3 into 1 is 3. N can be minus 1, 3 into minus 1 is minus 3. N can be 0, so 3 into 0 is 0. So n can be any number, any integer. Okay, so we have to remember n is an integer. And here we need to write that second part which says n belongs to integers. And close your brackets. This is a simple one. So how do we read it? X is such that x is 3n and n belongs to integers. That means in the place of n, I can put any negative number, positive number or 0 and I will get my elements of this set. Question 4, in that the first one is 1, 2, 4, 16 and 64 equal to this. And what does this mean? X is such that x is a factor of 32. That means here we have a set of elements. Here also we have a set of elements which are all factors of 32. Now what are all the factors of 32? Let's put it in the set. So 1 and 32 are factors of 32. Then we have 2 and 16. Then what else? Now 3. No, 3 doesn't go. Now 4 8s are 32. That's it. So these are all the factors of 32. Now look at this one. Here it says 1, 2, 4, 16 and 64. Can you see when we write factors of numbers, the greatest factor is the number itself. Whereas here we have 64. So we can say that this set is not equal to this set. So the answer is no. And the reason is 64 is not a factor of 32. So let's write that. So we can say no, 64 is not a factor of 32. Question 2. Here x is such that x is a factor of 27. So we have to write down all the factors of 27 and here it says it's not equal to this set. So this set is not equal to this set. So let's see if that statement is true. So let's write all the factors of 27. 1 into 27 is 27 and 3 9s are 27. So according to this set is not equal to this set. Let's see. Here we have 1, 3, 9 and 27. Here we have 3, 9 and 27 and 54. So this statement is correct. This set is not equal to this set. And the reason is again because 54 is not a factor of 27. Remember, factors are all numbers that are equal to or less than this number itself. It cannot be greater than that number. So the answer here, first answer will be yes. The first set is not equal to the second set. And the reason is again 54 is not a factor of 27. Okay, next question. Write the set of even factors of 124. So first let's write all the factors of 124. So what are all the factors of 124? So let's start from 1 itself. So 1 into 124 is 124. Now that's an even number, so we can write 2 also. So 2 into what? 2 into 62. Now is it divisible by 3? It's not divisible by 3. Is it divisible by 4? Yes. 4 into 31. 4 into 31 is 124. Now that's it. No other number will give us 124. So what are all the factors of 124? 1, 2, 4, 31, 62 and 124. So let's write that down. So factors of 124. So factors of 124 are all these numbers. What are these? 1, 2, 4, 31, 62 and 124. These are all the factors. Now the question says write the set of even factors. That means from here we have to pick out only the even numbers. So what are the even numbers? We have 2, we have 4, we have 62 and 124. So we have the answer, the set of even factors. We can give it a name, even factors. You can give it any letter in capitals. Okay, now let's write out all the even factors. That is 2, 4, 62 and 124. These are the even factors of 124. Question 4. Write the set of odd factors of 72. So let's begin by writing all the factors of 72 first. So 72, we need to get this, isn't it? Starting with 1. 1 into 72 is 72. Let's go to 2. 2 into 36 is 72. Now it is divisible also by 3. 3 into 24 is 72. It's also divisible by 4. 4 into 18 is 72. Then it's divisible by 6. 6 12s are 72. Then you go to, after 6 it doesn't go in 7, so we go to 8. 8 9s are 72. and then you go to 9, and 9 is already there. So these are all the factors of 72. So let's write down all the factors of 72. So factors of 72 are 1, 2, 3, 4, 6, 8. Then we have 9, 12, 18, 24, 36, and 72. These are all factors of 72. All these numbers are factors. Now the question says write the set of odd factors. So pick out only the odd numbers from here. So we have 1, 3, then what else do we have? 9, then that's it, 1, 3, and 9. So there are only 3 odd numbers among all the factors of 72. So now we have the set. So let's write down the set here. So let's name the set O for odd numbers. You can give any letters. Let's write the odd numbers 1, 3, and 9. So this is our answer. The odd factors of 72 are 1, 3, and 9. Question 5. Write the set of prime factors of 3234. So let's find the prime factors of 3234. This is the method that we use. 3234, we are going to divide it by prime numbers. So let's begin with 2. 2 ones are 2. What is left is 1. So that's 12. 2 sixes are 12. Again, we have 3. 2 ones are 2. There's 1 left, 14. 2 sevens are 14. Now we have this number 1617. What is this divisible by? It's not an even number, so it's not divisible by 2. Now let's add this up and see whether it's divisible by 3. 7 plus 1 is 8. 8 plus 6 is 14. Plus 1 is 15. That means this is divisible by 3. So let's divide this by 3. Let's take 16. 3 fives are 15. There's 1 left, 11. 3 threes are 9. There's 2 left, 27. 3 nines are 27. Now this number is divisible only by 7. So let's take that. 7 sevens are 49. Now what is left? Again there's 4 left. 7 sevens are 49. Continue again with 7. So here 7 elevens are 77. Now we can take 11 and 11 ones are 11. So now what are all the prime factors of 3234? The prime factors are 2, 3, then we have 7. We don't have to write it twice. 7 and 11. So these are all the prime factors of 3234. Now we can put it in the form of a set because we are asked to write that. Write the set of prime factors. So P is equal to 2, 3, 7 and 11. This is our answer. Question 6. Is this statement equal to this? So here what does it say? X is such that x square minus 7x plus 12 is equal to 0. Now we have to solve this and see whether we are getting 3 and 4. If we are getting 3 and 4 after solving this, that means this statement is equal to this. Now first thing we need to do is we have to solve this. So let's begin that. That is x square minus 7x plus 12. Now how do we solve this? Now this is factorization. So here let's take this number 12 and let's take this other number here, only the number minus 7. Okay, so we are going to take minus 7. Now we have to think of two numbers. When we multiply, we get 12. When we add, we get minus 7. So we have to think of two numbers. Think of two numbers that can give you 12. Now two numbers that can give you 12 is 1 and 6. 1 and 12. 1 and 12 is 12. You can get 2 into 6 is 12. You can get 3 into 4 is 12. Now, which of these numbers, when you multiply, we know that you get 12. Which of these numbers, when you add, will give us 7? Now, 1 and 12 will not give us 7. 2 and 6 will not give us 7. But 3 and 4 will give us 7. And 3 and 4, when you multiply, will give you 12 also. So here we're going to say 4 into 3 is 12. But here I can't simply say 4 plus 3 is 7, isn't it? Now 4 plus 3 will give me only 7 but not minus 7. Now how do I get minus 7 after adding these two numbers? I can get it only if I add a minus sign here, isn't it? If I say minus 4 minus 3, then I will get minus 7. Similarly here, minus 4 into minus 3 will give me plus 12. So what I can do is I can split this minus 7 into minus 4 and minus 3. So how do I write this? I write this as x square minus 4x minus 3x plus 12. So we have split this middle term. We have split it into 2. So even if we put this together, we're going to get back 7x. And when we multiply the numbers, we're going to get 12. So now we're going to take out the common factor. So we're going to make this one group and this one group, and we're going to take out what is common to these. So if you look carefully, you can see that this is x squared. That means x into x. There are two x's there, and here there is one x. So if since x is common, I can take out 1x. So I can take out 1x, then I'll put the rest in brackets. So here, since I've taken out 1x and here there are 2x, I need to put back one more x. So here I get x. Then I put the minus sign. Now here 4x, I've already taken out x. So I only have to put 4 there. So I have got 4. So here can you see I have taken out the common factor and I have put only x minus 4. If I multiply this, I will get back this. Now similarly, we should do here also. And this time you have to try to get x minus 4 within brackets there. So let's take out something that's common here. What do we take out? Now we don't have an x here, so I can't take x. Now look at the numbers 3 and 12. So 3 ones are 3, 3 fours are 12. That means I can take out the number 3. So let me write minus 3. Minus 3, and here what do I have? I have taken out minus 3, so what is left is only x. So I need to put only x inside. And here I have 12, isn't it? Now how do I get 12 inside? 3 fours are 12. So I can write 4. But what is the sign I'll put? Because I need a plus sign. It should become plus 12. That means this will become minus because minus into minus will make it plus. So this has now become minus. So now again, if I'm going to work this out, if I'm going to simplify this, I will get back minus 3x plus 12. So now can you see I have x minus 4 here and x minus 4 here. So I can take out x minus 4. So this will be x minus 4, the first common factor. And what is left is x minus 3. So I have x minus 3. So now I've got the two common factors. So the factors I have found. Now I need to find out the value of x. So here x, okay, so this part we have done it here. Now here is equal to 0. So here it says this is equal to 0. So let's remember that. So that is equal to 0. We have done split the middle term. Here we have got our factors, common factors, and finally we've got our factors. Now whenever you have factors like this which is equal to 0, each factor, that means x minus 4 is equal to 0 and x minus 3 is also equal to 0. So now let's write that x minus 4 is equal to 0. That means we can find the value of x. X is equal to 0 plus 4. X is equal to 4. So we found the value of x here. It is 4. Now let's look at the second one. X minus 3 is also equal to 0. So let's write that x minus 3 is equal to 0. So x is equal to 0 plus 3. So x is equal to 3. So we have found x here. So what have we got? We found x to be 4 and we also found x to be 3. So x according to this is 4 and 3. So we have solved this part and the question is this statement equal to this statement? And this statement we have found out to be 4 and 3 or 3 and 4. So this side is 3 and 4 and the other side is also 3 and 4. We have found out now, isn't it? So what do we answer? How do we answer this question? Is this statement equal to this? We say yes. So the answer is yes, the statements are equal. Question 7. Is this statement equal to this? So that means we need to first solve this and find out what are the elements. If it's the same as this other statement, then we can say yes. If it is not, we can say no. So let's solve this quadratic equation, this is called. So let's solve that. So here, just like the previous one, look at the last number. The number is 6. Think of two numbers which will multiply to give you 6. 1 into 6 is 6. Then 2 into 3 is 6. So these are the numbers that will multiply to give us 6. So we're going to use one of these, 1 and 6 or 2 and 3. Now we have to look at the number in the middle. The number in the middle is minus 5. Now which of these pairs will give me minus 5 when I add? Let me take 1 and 6. So 1 plus 6 will give me 7. But what do I need? I need minus 5. So if I change the sign here, if I change this plus sign, if I change it to minus, what will my answer be? My answer will be minus 5. So I am able to get this minus 5, isn't it? So what are the two numbers? When I multiply, I get minus 6. When I add, I get minus 5. The numbers are 1 and minus 6. So let's write that here. So that will be x square minus 6x. Okay, I'm taking it from here, minus 6x. Then we have 1 here plus 1x. And then we write minus 6. This is equal to 0. Now here I'm going to look at this first and then this. Now from here I'm going to pick out the common term. Here I have two x's, isn't it? X into x. Here I have 1x. That means x is common. So let me take out 1x here. So I have 1x. Now the remaining I'm going to put it within brackets. Here it is x square and there is one x out. That means I need to put one more x inside. Let's go to the next term. Here we have 6x. From that, x is already here. I have to put only 6 inside. Then let's go to the next one, plus. So here, as you can see, there's nothing common. When you have nothing common, you write 1. Okay, and inside we write the same thing, x minus 6. Because when you multiply 1 into x minus 6, you're going to get 1 x minus 6. You're going to get the same thing. So when you don't have anything common, you put 1 and put that same term, that same expression inside. Now this is equal to 0. So here we are going to take the common one. Can you see we have x minus 6 and x minus 6? So we're going to write it only once, x minus 6. Then what is left? We have x plus 1. So that will be the next factor, x plus 1. And both these are equal to 0. So when you have two factors that are equal to 0, it means that the first factor is equal to 0 and the second factor is also equal to 0. So that way we can find the value of x. So let's take the first factor, x minus 6 is equal to 0. That means x is equal to 0 plus 6. That means x is equal to 6. So we found the value of x here, one value we found. Now let's take the next one. X plus 1 is equal to 0. So x plus 1 is equal to 0. That means x is equal to 0 minus 1 or x is equal to minus 1. So we have found the values of x here. According to this, x is 6 and minus 1. Okay, so we found the value of x and x, that is 6 and minus 1. So let's write it here. So here this statement is giving us the answer 6 and minus 1 as the elements. But look at the elements on the other side, it's 2 and 3. So what is this question asking us? Is this equal to this? We know it is not equal. So we can say it is not equal to 2 and 3. As you can see, the elements are different. So the answer to this question is no. So this is our answer. Question 5. Write the following sets in the roster form. Now the first question, the set of letters in the word merit. Now we need to write this in the roster form. So how do we do it? We put it in curly brackets and we write every letter separately as small letters and put a comma after each. So we write M. So first letter is M here. Then we put a comma. Then we write E. Now remember the rule, you must not repeat letters. So I will not write the next E. So then R, U and T. So these are the elements of the set in the roster form. Next one is write the set of letters in the word universal. So here also we're going to start writing all the letters without repeating. So U, N, I, V, E, R, S, A, L. Now here we have written all the letters because none of the letters have been repeated. Question 3. The elements in the set A will be x is such that x is equal to y plus 3, x belongs to natural numbers and y is greater than 3. So what is x? All the elements of the set, and they are all y plus 3. And remember, y is greater than 3. So let's solve that. So y is greater than 3. That means what are all the elements of y? It can be 4, 5, 6 and so on, isn't it? So these are the elements of y. Now it says x is equal to y plus 3. X is equal to y plus 3. So in the place of y, let's put the first number 4. So if y is equal to 4, then x will be equal to 4 plus 3, which is 7. Let's take the next number, 5. If y is equal to 5, then x is equal to y plus 3, which is 5 plus 3, which is 8. Now, if y is equal to 6, then x is equal to y plus 3, that is 6 plus 3, which is 9, and so on. So, can you see the answers? 7, 8, 9. So, the next number will be 10, and so on. And they're all natural numbers because here it says y belongs to natural numbers. So let's write down all these elements of set A. So set A will have elements like 7, 8, 9, 10 and so on. So this is our answer. Question 4. B is equal to, P is such that P belongs to whole numbers and P square is less than 20. So look at the first part, P belongs to whole numbers. That means whole numbers begin from 0. Okay, so first let's write that part. So P will be 0, 1, 2, 3, 4, 5 and so on. Okay, then look at the second part. P square is less than 20. P square. So if P is equal to 0, P square will be 0 square, which is 0. Let's take 1. 1 square is 1. Now let's take 2. 2 square is 4. Let's take 3. 3 square is 9. Let's take 4. 4 square is 16. Let's take 5. 5 square is 25. So here the question says p square is less than 20. So let's look at all these answers but not take 25 because 25 is more than 20. So we can cancel out 5 square and 25 here. So now we know what P is. P is 0, 1, 2, 3, 4 and 5 because P square is these numbers other than 25 because the squares are all less than 25. So let's write down these numbers. So set B is equal to 0, 1, 2, 3 and 4. We stop at 4 because 5 square will become 25. So we have to get a number less than 20. So these are the elements of set B, 0, 1, 2, 3 and 4. Question 5. Set C is x is such that x is a composite number, and now when you get a statement like this, read it carefully by keeping x in the beginning. So now let's read it. X is greater than and equal to 5 and less than and equal to 21. So we have to think of all the composite numbers between these two numbers. So first let's write down all the numbers between 5 and 21 including 5. So that will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21 because it says equal to 21 also. Now among these there are many prime numbers. So if we circle out the prime numbers, then what is left will be the composite numbers. So let's circle the prime numbers. So here we have 5 is a prime number, 7, then we have 11, 13, then we have 17 and we have 19. So what I have circled are all the prime numbers. So what is left are the composite numbers. So let's write the elements of set C. Set C is equal to, let's write all the numbers which have not been circled. 6, 8, 9, 10, 12, 14, 15, 16, 18, 20 and 21. So these are all the composite numbers between 5 and 21. So this is our final answer. So let's stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.